Hello, today I will be solving problem number 74, search a 2D matrix. I highly recommend that if you already don't know the concepts of two-pointer or what is binary search, I highly recommend that you get good with those topics in order to solve this or understand this problem. With that being said, let's begin. So the question asks us you are given an n by n integer matrix with the following two properties. Each row is sorted in a non-decreasing order. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if the target is inside our matrix or false if it's not. You also must write a solution in O log m times n. So let's understand. Like we're given a matrix array, which is like a list inside a list, which has we're given that it is sorted, and the values inside the list is always in an ascending order. So we know that 1, 3, 5, 7, and we have also been told that the subsequent list also has integers that are bigger than the last index here, right? So if it's like 7, there won't be like a 6 here. It's always going to be in an ascending order, right? So 7, 10, 11, 16, 20, be here 20 is going to be 23. So let's understand like what's going on here. I have a diagram right here to like better like help you better understand what's going on. So we have a list right here, and inside the list we have three lists. For example, in this particular example, right, we have 1, 2, 3, which is one list, 4, 5, 6, which is one list, and 7, 8, 9, which is also another list. So we have to understand like inside the matrix, inside this list, at index 0, we have our list 1, 2, 3. At index 1, we have our list 4, 5, 6. And at index 2, we have our list 7, 8, and 9. And the index in within these lists, like within this list, is also different, right? So 0, 1, 2 for the list inside of our list, and then 0, 1, 2, 0, 1, 2. Those are all like all of the indexes. This is just a diagram to like help you better understand like what's going on, right? So to solve this problem, essentially what we need to do is we need to do binary search. Like we need to do a binary search for like the outside list essentially, and then check to see if the target value is in the outside list or not. And if it's not, then we can just check if the value is like smaller than like 4. If the value is 2, which is smaller than 4, then we just like say like, hey, the value exists in this list, so we do a binary search within this list. And if the value is like 3, we do binary search, we land in 2. We say 2 is obviously bigger than our target, 2 is obviously smaller than our target value, so we increment our left pointer here and we just find the target value. So with that being said, let's code it up. So first we can like initialize our row and columns. Essentially we can do row will be just the length of our matrix, right? So as you can see, the length of our matrix is like 0, 1, 2. So row will be that, and then columns would be the length of matrix at the 0th index, because like we're uh, it doesn't really mention here, but it's like pretty evident that there will be like if there's like a row 1, 3, 5, 7, the columns will essentially match the second row as well, right? So it has 0, 1, 2, and 3. So it has like 0, 1, 2, and 3. These are the columns, and these will essentially match the other columns of the other rows as well. It's like pretty evident in this question. So we have initialized this. This will help us keep track of initialize our top and bottom pointers to do binary search within our first list essentially. So we can say top and end. So top would be like at 0. Top would be right here, and end would be at right here. So we can say top is at 0, and then end is at the row minus 1, right? Because we initialize row to the length of our matrix. So row is pointing right here. That being said, we can do our binary search part. We can say while top is smaller than or equal to our end, mid is equals to top plus end divided by 2. This part of the question we were just doing binary search. again, I'm gonna say, if you don't know, if you really don't know binary search, that you, before even solving this problem, you should really understand what binary search does. Now we can say if the target is smaller than the, like the mid, or sorry, matrix mid 0, right? So like what we're saying here, if the target value is, if it's smaller than the value we have at the mid, at the 0th index. So like if our target value is at, like, example 2, right? We check the target value, this one first. This is obviously bigger than like 2, so we know that we have to check here, right? Because if you were to check like down, it's just gonna keep ascending, so we can't really find our value. So we do this and we say end is equals to mid -1. So end is initialized to here now as well. Now we can do our binary search in this pen. But otherwise, if the target is bigger than our matrix at mid, at the very last index, like we have, so our mid is right here right now. To check to see if our target value is, if it's not this or bigger than this, we check like the last index, right? If our target was 9, we would check the last index and we would say, hey, well, 6 is obviously smaller than 9, so top becomes, this. So we can do binary search in this part as well. So we say top is equals to mid plus 1, else break. Like if we can't find it in the top, in the top matrix or in the end matrix, we just break. And then we can say like, hey, if the top is bigger than our end, if the pointers have crossed, we can return false, because the target value does not exist in any of the lists, right? So we can just return false. That's what this does. Now what we can do, we haven't really checked the middle matrix that we landed at, right? So if the value is inside the middle matrix, we can do mid is equals to top plus bottom divided by 2. So we land on middle matrix, and I'll explain why we did that. And we have a left and right pointer. So left would be at 0, and then so left would be right here, and then right will be right here, right? So it'd be like column -1. As you can see, we initialize column to the length of matrix at 0. So it would be like right here. So it would point like right will point here. Right, so we can say while our L is smaller than or equal to our right pointer, we can say if the target value is smaller than the matrix at oh, we didn't even do the binary search, my bad, mid 1, we can say mid 1 is equals to left plus right divided by 2. So that's why we did mid again, right? Because we want to land in this array. So we say if the target is smaller than this value in this, like we're in this at mid 1, which is like, let's say we landed right here. First we did, like, we landed inside this in this array, and then we did a binary search inside this array, and we landed at 11. If the target value is like 10, suppose, so we can just say, right, we know that we can find our solution in the right side. We can just say right is equals to mid 1 -1. And evidently, so we can do the same thing for our left pointer. If the target value is bigger than matrix at mid 1, we can say left is equals to mid 1 plus 1, else return true, right? Because otherwise, like if the value, like if it's not this, if it's not this, like it has to be in the middle, right? Like 11 is our value then. And if nothing matches, we can just return false. We can break outside of our loop and return false. And as you can see, this should work. Oh, my bad, I use bottom here instead of end. This should work, I believe. Yeah, as you can see, let me submit it just in case. Yeah, as you can see, this works.